In question 2 we're dealing with lightweight Walker armour. I've put a little picture of a smaller version than we're dealing with in the question up here, just so you've got an idea of what that might look like. It's got a mass of 9.90 kilograms. What's the difference between mass and weight? Mass is the amount of matter in an object. Basically that comes from the atoms that make it up, and the weight is the interaction of that mass in a gravitational field and the resulting force from that. And then we're asked to do a calculation. So mass measures the amount of matter in an object, in this case the Walker armour. Weight is the force exerted by a gravitational field. And our calculation, using the guess method, we write down what we've got, what we don't know, identify an equation, force equals mass times gravitational field strength. I've put in a little W here, that's how I like to write my weight force, so the force weight is the W, and that equals 9.90 times 10, giving us 99 newtons. Okay, so in part B, we're asked to calculate the pressure exerted by the Walker armour on the water. So we're assuming that the hulls are rectangular in shape, one with a length of 6.55 meters and a width of 0.4 meters, and the extra little part is 4 meters in length with 0.15 width or depth. So we need to work out the area first, and then we're going to use the area with the weight that we previously calculated to find the pressure of the Walker armour on the water. So our first area is 0.4 times 6.55, and our second area is 4 times 0.15. We add those together to give us 3.22 meters squared. Okay, so using that area and the previously calculated weight force of 99 newtons allows us to substitute into the equation for pressure. Pressure equals weight force divided by area, and the weight force is 99, the area is 3.22, and that comes out at 31 pascals. You don't really need to worry about significant figures at level 1, but I've put that in there just to show what I would have rounded it to. And that's based on the smallest number of significant figures in the data that was given. Okay, so part C, the Walker armour sinks further into the water when a 67 kilogram paddler sits in it, and the only pictures I could find for free use were these ones, so apologies if they don't quite fit what's going on. Explain why the Walker armour sinks further into the water when the paddler sits in it. Use calculations to support your answer. So we've been given the mass of the paddler, so we'll be able to work out a new weight force and a new pressure based on that as part of our answer. So the weight force is mass times gravitational field strength. So the weight force this time is a combination of those two masses times by 10, which gives us 770 newtons. And referring back to our formula for pressure, since the pressure equals force divided by area and force is larger while the area remains constant, pressure must increase. It's important to state the variables that remain the same. That's often part of a requirement for excellence in these explanation answers. So make sure that you talk through each term in the equation in order to get full credit. So in this case, the new force of 770 divided by the same area of 3.22 gives us 240 pascals, and this causes the Walker armour to sink further into the water.